Hello students, welcome. In today's session we are going to look into a traveling salesman problem. In the previous video I had given you a good insight into traveling salesman problem and what are the different steps that is used in traveling salesman problem. This is a type of assignment problem. Now looking into the question, what should be the sequence of the salesman's visit so that the cost is minimum? And a traveling salesman is supposed to travel to 5 different cities A, B, C, D, E, and the matrix is given. Now we'll look into the problem. So as you get the problem, you first of all put infinity values in the diagonal matrix. Now we look for the column reduction. Now look into this particular row reduction. Look into this particular row and check which is the lowest value. This is the lowest value. Look into this particular row, which is the lowest value. This is the lowest value. In this particular row, lowest value is 4. Here the smallest number is 4. And here we have 1. Now we'll go for row reduction. So what we'll do is we'll minus 1 from all the other elements of that particular row. So this will become 2 minus 1, 1, 5 minus 1, 4, 7 minus 1, 6 and 0. Now here we'll reduce 2 from all the other numbers. 6 minus 2, 4, 3 minus 2, 1, 8 minus 2, 6 and 0. Minus 4 from all the other numbers. 8 minus 4, 4, 7 minus 4, 3, 4 minus 4, 0, 7 minus 4, 3. Next we'll do is minus 4 from all these. It will become 8, 0, 6 minus 4 minus 6 minus 4 is 2 and 5 minus 4 is 1. Here reduce 1 from all the other numbers. 1 minus 1, 0, 3 minus 1, 2, 2 minus 1, 1, 8 minus 1, 7. So this is the resultant matrix. Now we'll go for column reduction. Now first we did the row reduction, now we'll do the column reduction. Look into this particular column. Now here in the column, check which is the lowest number. Which is the lowest number here? We have 0 here. So sorry, this is actually a 0. We have a 0 here. In this particular row we have a 0. In this particular row there is no 0. The least number is 1. So circle 1. Here we have a 0. Here we have 2 zeros, so we'll take any one. So now we'll do the column reduction. Now what is column reduction? Look at this particular column and minus that particular number. Now these are zeros, so there will be no change. So we'll just write the same thing. Infinities to be put initially. Then we write it 4, 4, 8, 0, 1, 3, 0, 2. Here there is a change. We have to reduce 1 from all these numbers. So 4 minus 1, 3, 1 minus 1, 0, 2 minus 1, 1 and 1 minus 1, 0. Now look into this, there is no change. 6, 6, 0, 7, 0, 0, 3, 1, infinity. Now we'll check for the assignments. Now we'll try to do the assignments. Now look for the first row. Yes, there is a one single 0 there. When there is a one single 0 there, put a square and delete the entire column. We are going for row scanning. Now go for the next one. Here there is 1 0. Okay, so we'll take that 0 and we will delete the entire column. Now here again, yes, there is one single 0 here. Take that 0 and delete the entire column. Yes, again we have a 0 here. Delete the entire column. Now again we have a 0 here. Very good. This is a very good traveling salesman problem. We got it in first shot, but now we have to check whether it is taking into the consideration of the method that is to be followed for traveling salesman problem. Now what are the two rules for traveling salesman problem? The first one is the salesman should travel through all the cities and only then travel to the initial destination. Okay, so let's check whether the salesman is traveling through all the cities. Now here the route is like he begins from A. He begins from A and then he reaches E. A to E. Then what happens from E again reaches A. From E again reaches A. Now that is a problem. That is a problem because he is reaching the initial destination without covering the other cities. Now what we are supposed to do next? Now this condition, when we look into the Hungarian method, we have reached the conclusion, or we have reached the optimal matrix, because the number of lines drawn, that is 5, is equal to the order of the matrix 5. Now see, number of lines drawn 1, 2, 3, 4 and 5, and the order is 5. But we might have reached, as per Hungarian rule, into the conclusion, but as per traveling salesman, the criteria is not satisfied. So we'll do a small trick, or rather we'll do another small change into the allocation. So what we'll do next is we'll take the same matrix and we will allocate for the next highest number. Now see, I'm writing the same matrix here once again, infinity. How I am doing this? I'm going for the next highest number in the entire matrix. From the least number was 0. The next highest number that is available is 1. So in the first allocation that I'm doing, that is the first row, you can go for the next highest number. What is the next highest number? 1. So allocate 1. We're not going for row reduction, column reduction, nothing. We're directly going to a second alternative method of allocation. So we are going for allocation in 1. So what we do next is treat 1 as if you are treating 0. Okay, and then you allocate it for that and you delete the entire column. After that, what we are supposed to do next is go for the next row. Next row, you see 2 zeros. There are 2 zeros, so skip that particular row. After that, what you see next is, here we have 1 0. Okay, 1 0 is okay. You can take 1 as well as balance everything, treat as if you are doing the normal. So you can allocate here and delete that particular column. Now when you look into this particular row, you have 2 1s here. You cannot take both these ones because there are 2, just like you're treating any zeros. When there are 2 zeros, you just skip that row. Now skip that row, go to the next row. Again here there is a problem, you have 2 zeros. Okay, now we'll go for column scanning. Look at the first column, you have only 1 0. Allocate there and delete the row. Now you have the second column, it's already been taken. Go to the third column. Now in third column you have a 0 and a 1. Whenever you get a 0 and the next higher allocation, go for 0. Okay, so we'll take 0 here and then delete the column, delete the row. Now again we go for this, is already allocated. Now let us look into the last column, column E. Now when you look here, you have a 0 and a 1. Now there is a small problem, that particular row is being taken. Had there been a 0 and 1, you are supposed to take 0, but the entire that row is being taken. So because of that, we are allocating here in 1. So we allocate in 1 and delete the entire row. Now let us check if we have reached the final optimization route. The traveling salesman route is from A he is going to B. From A he is going to B. From B he is going to C. From B is going to C. From C is going to D. then from D is going to E, and from E is going to A. From E is going to A, correct. So we have come to the final optimization route of the traveling salesman, that he will be traveling from A to B, B to C, C to D, D to E, and E to A. He has reached the initial destination finally. We'll also look into the traveling cost. The traveling cost is allocation 2 plus 3 plus 4 plus 5 plus 1, which is equal to rupees 15. So this is the optimized table, the route as well as the minimum cost that he would incur. So I hope you understood how to solve the traveling salesman problem. I am putting a example question for you to practice. So thank you very much.